So, we have been looking at the probability and statistics and then try to see how that could help us in terms of solving some of the problems in NLP. So, in continuation of that, I am going to be looking at naive-Bayes algorithms for NLP. So, I am going to give only the very high level overview of this, and you may want to go and then read this in detail in the reference books. All right. Okay. So, here what we are going to show is we are going to be showing how a naive-Bayes can be used for classification. So, it would act as a classifier, and then we will see how we can utilize that in terms of classifying two different sets of data. All right. So, in this case I am going to be considering emails. Okay. So, let us consider two people, Ram and Raj, who are exchanging emails. I have just taken some small portions of the email and I have listed here as documents. Okay. So, this set is by Ram and this set is by Raj. Okay. And then these are very simple text that I am considering as email messages, and then at the end I want to find out who had sent this mail that contained so many words. Okay. Assuming that this mail has come without any name or anything and you are asked to find this. So, this is the situation in various other classification applications as well. So, instead of emails you may want to look at spam, right. So, whether a mail is a spam or not a spam. So, in that case, when the incoming mail is not known to be a spam initially, right, but by looking at the contents of the data you may want to tag it to spam or not spam. So, in this fashion we are going to be considering this as the incoming email, and we want to classify whether it was sent by Ram or Raj. Okay. So, what do we do in the statistical modeling? We start looking at the numbers of the occurrences of words, right. So, that is what we want to do. Can we just do it without any help from the probability and statistics to find out whether this mail has come from Ram or Raj? Yeah, there is a possibility, since the sizes of the emails are small, right. So, in this class as well as in this class it is very small. So, we may be able to find out how many times Ram had sent the email containing the word I wish you would come and so on, and then count how many times Raj had sent using those words, and maybe that would give approximately who had sent it. But that is not going to help us in the cases where the contents are huge. So, let us look at how this could be mapped into the naive-Bayes, and then let us see how we can solve step by step, right. Okay. So, before that I would like you to remind you that we are going to be using bag of words. I am sure you remember what bag of word is. I have just represented this using some simple graphics. So, we have the same set of emails coming in from Ram and Raj here, right. The bag of words, you know well that it just takes each and every word and then we just dump it into the bag. So, there is no organization with respect to the sequence of words that is getting into the bag. So, it is all jumbled in some fashion. The output of this would be for every word what is the frequency, because that would be the output of the bag of words, correct. So, again in this case we are going to be looking at the Bayes theorem to find out whether the mail had come from either Ram or Raj. So, bag of words is going to be the part and parcel of this algorithm for us. Okay. So, before getting into the algorithm part, let us look at the theory aspect first and then see how we can map the theory into the email classification problem, and later start doing later we start solving this particular problem. Okay, so let us consider two random variables. So, I am just taking the theory part of that initially. Okay. And then you know what a joint probability is, right. So, it is given as this. So, this refers to the probability that the variable x, capital X, takes the value small x, and the variable capital Y takes the values small y. And then you also know what a conditional probability is. Okay. It is represented as this. It refers to the probability that the variable y takes the value small y, given the observation of the variable capital X taking the value small x. Okay. And you know that the conditional probability can be represented, rather the joint probability can be represented as the product of conditional probability, right, and Px. So, the same can be represented in this fashion. So, taking these two, right, and then trying to form an equation. So, where P of so we are looking at this one now. Okay. So, where we are trying to find out the conditional probability of y given x equal to this, right. It is pretty simple, isn't it? Okay. So, now how do you map this? So, now we have obtained two parameters, right. This. So, I am also going to let you figure out why I am not going to be using Px beyond this point. Okay. So, I will not be considering Px. So, you have to go and then look at the reference books to find out why a probability of x does not really matter in this case. So, we are going to be mapping this Bayes theorem to email classification problem. Let us look at some of the statistical properties of the data. So, that is very important, right. So, we need to understand the data in order for us to really do some progress in terms of finding out what is in it, what can I do with it, and how can I solve the problem that is on hand, right. So, let us x be a variable that contains variable parameters x1. I am sorry, I somehow missed that part. So, I am going to be writing it here, x, that is capital X equal to is a set of variables okay, and then y represent our class. Okay. So, sorry, there is some error there. So, y is a set of attributes, and x, I am sorry, let x be equal to set of attributes, and y represent a class. Okay, class containing now it is only one class. So, it can also be a capital Y containing multiple classes as well, right. So, we want to find out the relationship between x and y. So, let us use the conditional probability to find out the relationship between x and y. Okay. So, in this case since we are going to be finding this, this is the posterior probability of y, and Py is known as the prior probability. Okay. So, we are doing it from here. Okay. So, in the classification problem, it is important to learn the parameters of this conditional probability. So, given the attributes of the email, so you can either use the term frequency, TF-IDF or any combination of weighted TF-IDF or just TF alone and so on, right. It could be just the term, or you can use n-gram also to find out the parameters or the attributes of the email. Okay. So, what we want to find out is, given these set of data and having all the attributes for each of the data set that we are going to be using, we want to find out to which class a new document that comes in belong to, right. So, given the attributes of the email, right, and given the prior probability. So, we want to find the class to which the email belongs. That is, in this case, who is going to be sending it, getting the point, right. So, now what we have a set of data, let us call it as the training data set, which contains all the emails from both parties, or we can call those as two different classes of emails. And then every email that you have contains a list of words, right, that we can call as the attributes. And then based on the combinations of the words that are present in the email, we want to classify whether it belongs to the class 1, which is Ram, or Raj, or class 2, right. So, that is what we want to find out. So, now looking at those contents of the email, how can I take the attributes out of that? That is where TF and TF-IDF or bigram frequencies, all those things would come into play, right. So, now we have the data set that has been extracted from the training samples. So, now how can I now go and then find out who had sent the mail in that case, which one is that? So, we want to find out based on the training data that we have, or the labels that we have created, we want to find out who had sent this particular mail. Okay. So, the assumption is that the words that are there in this are part of this, part of the data set, right. So, if they are not there, so what do we do? So, we will look at that little later. Okay. So, now is this clear? So, we want to map the Bayes theorem to the classification problem. So, it is pretty simple. So, we are trying to find the conditional probability of set of attributes belonging to a class. That is, this x could be your okay. So, we want to use this x and then find out which class it belongs to. Okay. All right. So, as I mentioned earlier, now we have a set of input parameters x, which can be represented like this, and we have a fixed set of classes. So, in this case it is 2, right. So, if you look at the spam based one, it is going to be spam, not spam. And then if you look at the movie reviews, it is going to be positive, negative, or if it is about the reviews of any product, it is going to be positive or negative. The third class also could be neutral. Okay. So, the same thing could be extended to multi-class as well. Okay. So, now we are going to be looking at various attributes of x with varying length, and then we have a fixed set of classes y, which is y1, y2, yn. In this case, as I mentioned, we have only 2 classes. Okay. So, every element of the training set, so we can consider that as a document 1, 2, 3, 4, 5 and so on, is manually assigned a class, right. So, we have set of emails So, we already have manually assigned those values, right, to this class. So, we have set of emails and we have assigned each one a class. So, that is the manual assignment that we have made. Okay. So, the goal is to learn the classifier based on the data that we are going to be having, so that it can map a new document D to any of the class Y belonging to capital Y. Right. So, when we get the new document, the document is I wish you would come here. We are going to be mapping that particular document into one of these classes. So, that is the idea. So, what we are going to be doing is, in this case we are going to assign a probability to each of the class. So, we need to find out what is the probability of that particular document belonging to Ram or Raj, and then based on the values we are going to be picking up whether it belongs to the class Ram or Raj. Okay. So, we are going to be computing the probability score for each class using this equation, right. So, this class would be found using the argmax. For example, in this case there are only two values. So, we will have values corresponding to this. Let us say this is the probability score, this is the score. Okay. So, based on this score we will find out. So, this belong 1 and 2. So, we will find out which one has a higher value in this function and then pick up that index as our class. Okay. All right. So, how do we estimate the conditional probability? So, for each attribute that we have, given the class, we will find the conditional probability. Okay. So, for example, in this case we have I, right, probability of I given Ram. So, this is what we are going to be finding every time for every word in the corpus. So, okay, as I mentioned earlier. So, this is going to be for one word, right, and then for every class, since it contains about 4 or 5 words. So, we have to find out that conditional probability and then multiply that. So, when you do that you have estimated from the data all of these, right, for every class, and which can be written in a simplified fashion in this way, right. For us to find that, so we have a few parameters that we can estimate from the data. So, one is the prior probability for that class. So, we are going to be finding, since we are going to be having only 2 classes here. So, and then the sets of emails are the same. So, we have P of y equal to half. Okay. So, if you have more number of classes, that depends on how you have actually classified the documents, and then it goes by the document count as well when you take this up. So, in this case, since the number of documents are the same for both classes Ram and Raj, this is half. Okay. So, this can be estimated, and then since the class is known, so we are going to be assigning the probability for each and every variable. When you expand this, this is nothing but the conditional probability for that word given the class. So, for every class and every word in that class, we are going to find the conditional probability and then multiply that. So, we get, in this case we are going to get y hat will have 2 values, got it. So, that is where so then for every class, once you find that, and then use the argmax function to find out which index has the highest value and pick that up. Okay. So, let us take this example and then see how we can compute this. As I mentioned earlier, this is going to be half, right. So, we need to learn the parameters given the class for every word, find the probability. Okay. So, it is nothing but the count of x1 in that class and then the total number of words in the entire corpus. So, what you do here is there are two sets here, right. So, we have 1 to 5, 1 to 5. So, you combine all of this and then count the number of words, that is what going to be the count here. And then for x 1, count the number of x 1 in one class. For example, in this case for Ram, compute this, and then later for Raj, compute the same thing. But this remains the same for the computation at the. Okay. So, I need this space. So, what I am going to do is I am going to just copy some of those computations that I have done already. So, let us start with okay. So, this value is going to be 6 by 67. I think the number of words for Ram is 32 and Raj is 36. Okay. So, in the same fashion you do for all the words and this will be 2 by 67. Let me use a smaller, sorry, 68. And so on, right. So, you do this for Ram and then now do this for Raj. So, this will be 5 by 67 . Sorry, this should be 68. Aha, we got 1 0 here, right, and so on. So, once you learn these parameters, so now we have a table that contains all those values, right. So, now how can I use it to find who had sent that mail? So, if you want to find out this, see we are going to be using this formula, right. So, we are going to be multiplying all the conditional probabilities along with the prior probability. So, when you do this, we are going to have in the first case we have half, that is equal to p by y, right. I am sorry, that is the prior probability for this class, and then we have 6 by 68, 1 by 68, and for u this is going to be 1 by 68 again. There is no wood, I guess, in this, so it's going to be 0 and so on, right. So the value is going to be 0 because we have encountered a word that's not part of the dictionary that we have, right. So again, if you look at the other one, so you will have the same problem. So how can we solve this problem? So using this, it is not possible for us to find out who had sent the mail. So in order to solve this problem, what we do is we do a add one smoothing to each one of the variables. So in this case, we will add, instead of 6, we will add 1 here, 1 here, 1 here, and so on. So when you do that, it's not going to become 0. So we will always have some value associated with that. So the most important thing is add 1, this plus 1. So for every word count, you add 1 to that, but don't change the count at the bottom. Okay. So this is a very practical problem that you will encounter. So it is not always possible to satisfy a constraint every time, right. So in this case, wood is not part of the corpus, so but it has come, but we still have to take care of that and then solve it. So that's why this kinds of smoothing is done, where you add plus 1 to each of the word. Okay. So in this case, once you compute all this, you will find that this mail had come from Raj. Okay, all right. So is this clear? So you encounter always these kinds of problems in natural language processing. So every corpus is not complete by itself in terms of the vocabulary, in terms of the size, in terms of the lexical variety, and so on. Okay. So we deal with these kinds of problem as and when we proceed, and it's very important to understand the domain in order for us to solve this problem. So that's why we always keep looking at the content before we really extract parameters, whether it is the probability based approach or neural net based approach. It's very important for you to have a good handle on the data. Okay. And then it's also very important for you to find out what kind of parameters that you want to use for any problem that you may encounter in the natural language processing. So in this next slide, what I have shown is a problem. Okay, so the problem for you, this you may have to go and then either solve it by hand or use some Python programming to solve this problem. And I have given the attribute values. So instead of you counting and computing all that, so I have compressed and then reduced the work for you. I have computed some values and then provided them here, and this is the historical information that you may want to use. Again, there are only 2 classes. Okay. So what you want to find out is when an email comes with these 3 words, who had sent this mail. So it is very similar to what we have done earlier, and I think you will be able to solve this quickly. So it does not contain any OOV in this case. Okay. So you can also apply the same mechanism as I mentioned earlier, that we can find the sentiments of a movie review or product and so on, right. Okay. So there is one more problem also that I have given. So in this case, again, it's a sentiment analysis or a positive or a negative review. So, again to make your life easier, I have given 2 classes and the vocabulary and the values corresponding to each class. Okay. So, at the end of this you need to find out what is the class the Bayesian classifier would assign this particular sentence to. Is it positive or negative? So, you may want to use either hand calculation or you may want to write a small program and then later extend it to multi classes.